Hello, data leaders. This is Les Muller. I am your host on the Data Leaders podcast, and today on the show, I have with me Eberhard Jakobi. Eberhard is the head of HR Management Information and Analytics for Germany over at Deutsche Bank, and he is speaking at our Data Leaders Transformation Roundtable taking place in Zurich later this year. He will be speaking about a very interesting topic, which is predicting uncertainty. And Eberhard, welcome on the show.
Hello, Les. Many thanks for the invite and many thanks for the opportunity. As I said in the discussions before, I'm really looking forward to the event in Zurich. It's the top event in my calendar this year. So happy and thank you for the touch point.
Absolutely. It's our pleasure to have you both on the show and on the roundtable. And I can tell you now, as I also told you in the conversation earlier, that the attendees are looking forward to meeting you as well and hearing more about that, very, very relevant topic. And for those audience members who do not know you yet, there might be a couple. Can you just tell us a little bit about yourself and also your background and your journey of becoming a data leader?
Certainly, love to. I joined the topic in 2016. An opportunity opened where I could enter people analytics at Deutsche Bank. I've had some touch points with these topics previously in consulting projects, which were very interesting, and so I easily accepted the offer. Modeling analytics is kind of long-term interest of me. My previous academic career was involved with quantitative modeling. I studied physics, mechanical engineering, and did lots of modeling based on empirical data or phenomenological ideas. So I'm quite used to it and I love it.
Fantastic. And what are some of the milestones of your career? So if you think about, a significant events that happened to you that might have shaped, your journey, are there any particular of those that you think are worth pointing out?
Well, shape, yes, certainly. There's some kind of guiding principle in my career, and this is the modeling and analytics stuff. So I completed 2 different master degrees in physics and mechanical engineering. Afterwards, I deepened the physics studies into a PhD, did a lot of many particle physics there. Afterwards, I was in strategy consulting with the Boston Consulting Group for 5 years, where I was in the financial institutions and technology advantage practice areas. So the academics were quite of help, and the later strategic education and the experience in the Boston Consulting Group helped a lot to have these discussions at Deutsche Bank. And 2015-16, I joined Deutsche Bank and beginning with people analytics. And yeah, this was my academic career.
Yes, and in the world of analytics, actually predicting uncertainty, it's a very hot topic. People are looking for best practice. Why did you choose this, particular area, the kind of substructure of the analytics and statistics universe?
There are 2 observations I made, which led me to the conclusion that we had underestimated the relevance of uncertainty in our communication. First one is flight risk is not only a relevant topic of its own, but also is an interesting toy problem. Hence, we are investigating this for probing new methodologies, tools, new analytics, etc. In that case, we were stuck when we tried to create individual forecasts on the basis of macroscopic data. That means you easily calculate a flight risk of 2.5% for a certain group, but this cannot give you a sensible forecast for individuals. So if you're asking, we have 2 people out of 100 which probably will leave the next year, the immediate question afterwards is, who are these 2 people, or who's the risk group within the 100? Second observation was in a senior management setting where we were arguing about the change of forecast value for a head count, and this value from month to month change single digit. So the value changed from 100 in the forecast of July to 103 in the forecast of August to 101 in October and so on. This was just due to actualized data. The change itself was insignificant, as the statistical uncertainty, which we had not shown in the forecast, was dominating the outcome. So we were predicting / forecasting a value of 100 plus minus 5 or plus minus 10, but due to numerical changes from month to month, this was jittering slightly. And we had this senior management discussions, which were completely insignificant as the overall statistical uncertainty was dominating the outcome. And this was not a matter of lack of precision, not a lack of data. It was simply the true unknown in the problem. Hence, decisions, in particular individuals' decisions, have not been taken. They're still to come, and they affect the reliability of any exact number of forecast. So this was the interest. These were the two interesting observations, and they perfectly connected to my academic education in physics. Quantum mechanics require uncertainty as an intrinsic feature in translating microscopic behavior into macroscopic observable effects. I did lots of so-called quantum Monte Carlo calculations which cater for this uncertainty via Monte Carlo techniques. And so this was kind of a perfect match, observing the same patterns in the discussions I had before and people analytics.
Yeah, it sounds like, your experience in a completely different field than HR analytics. So, being astrophysics and quantum calculations, they kind of came together nicely to actually result in something, beneficial, hugely beneficial from a business perspective.
Absolutely.
And regarding that particular project, so I imagine that even with your background and having access to all those algorithms and techniques, it must have been challenging. I mean, what were your main challenges while you were conducting these projects?
Interestingly, it was neither methodological or the technical ones, but was the communications piece. You can easily build up the machine doing all these analytics, but the recipients of your results typically have not a mathematical or physics degree, and therefore are not familiar in talking about uncertainties, standard deviations, normal distributions, and all that stuff. Typically, they clearly understand the requirement. They follow the phenomenological story, but they are not used in reading and interpreting the figures in detail. This leads to questions. Why the standard deviation of combined events is not simply the sum of the deviation of the single events only, etc. And just by that, you have some additional effort in communicating the stuff which reads easily in mathematics, but needs to be translated in understandable patterns and formulations.
No, absolutely. And actually, I think this is one of the biggest challenges for people working in analytics and data management, because I think, naturally, people who are really good in statistics and math and physics, tend to be, maybe, less effective in terms of interpersonal communication sometimes, than people whose job is solely that. It's really tough to find that balance. And what skills and techniques and strategies did you find to be useful during that journey?
I do think the technical part is crucial. The mathematical pieces require, from my point of view, a mathematician or physicist in the first place. I would not expect it to be possible to develop the foundation for these approaches without robust education in these. In the second place, it's reasonable to carefully check and counter-check any of the outcomes. Given the complexity of the mathematical approach, the technical implementation is heavyweight and one easily loses oversight. Hence, careful and timely implementation of that stuff is mission critical.
And what advice would you give to people who are working on similar projects? I think you already pointed it out, but from a more hands-on perspective, do you have any tips and tricks that they could deploy right away when they go back to their business to apply some course corrections to their current approaches?
Well, it's quite general. Nonetheless, be cautious, be curious, have fun in mathematics.
Okay. Sounds good. Sounds simple enough, but a wise man once said that the best advice is always the simplest advice. So, I'm sure that our audience members can take this to heart. And talking about your specific session, so our format is quite unique in terms of is structured in a way that allows you to give a presentation and present a case study in the beginning of your session, which takes around 15-20 minutes. And the audience members will be able to ask you specific questions. And given the fact that it's a very small and intimate meeting, with only senior professionals from big brands being in the room, you can get quite specific. And then you will have the opportunity to pose a thought-provoking question to the audience, which will serve as an anchor for the group discussion. And then each table will present their solutions to the entire group, and you can then kind of outline the final conclusion. So predicting uncertainty, what will your session cover exactly?
I've not yet developed it, but I do have some key ideas. I certainly will present why, from my point of view, uncertainty is an issue and why it's crucial. I will, just for the people who have not been used to it or who don't know yet how that works, how this is going to work, or which possible approaches you can take. And I will focus certainly on the war stories and use cases we've recently applied. So it's becoming tangible how we not only developed it, how we applied it, and how we communicated this.
Yeah, the war stories and the case studies are always a very important part. So we always want you guys to be able to walk away with more than just interesting ideas and inspiration, but we want you to be able to grasp some actionable insights as well. How do you think that the audience members will be able to put those insights into actions? If you can think of a couple examples, I know that the specific session is not developed yet. So it really depends on the audience, but how do you think they will be able to improve their business results?
What my aim would be, and I've done that in different contexts for different analytic piece in the past. I would tailor the presentation in that way that you can quite easily derive toy problems or toy solutions from that, and by that learning and gaining experience in that reality and that topic. And so it would be easy to do your own toy problem on your own laptop with Excel, and learning that you can scale that to larger applications later on. So that would be my intent.
Fantastic. And I know that, the presentation itself will kind of take shape as we go along, but from your point of view now, if you had to capture only one idea that you would want the group to walk away with, what would that be?
The past is just one possible outcome of billions of options. If there were any differently taken decision in the past, this could have changed the reality today and the observation today. So whereas retrospectively everything looks simple, a simple and true forecast must reflect the multitude of these options which have not happened, but which will happen in the future. So it is a wrong, but unfortunately often taken assumption that today is some kind of an average of these past decisions or the most probable outcome. It is simply any of the possible outcomes when you had a look at today from a point of time in the past. And seen from the past, the situation today was uncertain to come. Hence, a sensible forecast or prediction requires to incorporate this uncertainty not only to predict the most probable outcome, but to also predict any other outcomes or give reliability estimates on the prediction of the figures. So covering uncertainty is crucial for doing forecasting.
No, that is very interesting, and yeah, Eberhard, we really look forward to the session itself. And I'd like to get your take on some future trends and tech as well. It might be connected to your session. Are there any particular trends and technologies that you are excited about today?
Yes, I am, but this might not be a surprise. Artificial intelligence. Honestly, I had underestimated this in the beginning, but we have started to invest time in this in the last couple of months. What struck me is the potential in the simplicity of the application of artificial intelligence. It's extremely promising, but we understand that the training of the neural networks must be done carefully, relating to the context we have. But we already have some smaller application at the end of last year where we benchmarked compensation data and created market compensation data for non-existing markets and profiles, or where we hadn't any data at all. And so this was a surprise, and yeah, this is where we currently love to invest time.
And what do you think about the time frames? I know that it's the development of AI is accelerating rapidly, but businesses find it difficult to actually implement it and get results from it. This will definitely improve over the next couple of months and years. What kind of time frame do you think is realistic? So if let's say you're an HR analytics person at a large company, and it can be a financial firm, or it can be consumer goods, business services. What kind of timeframes do you think are realistic? When do you think people will be actually able to drive tangible results from it?
Right now, already, but I do think this is starting from some lighthouse applications where you have selectively have applied artificial intelligence, and you need to learn and see whether this improves the insight you had before or improves your results. And this will certainly further extend. I do think this is been growing, and if you are asking when this will dominating any question you have, I suppose it will take at least 3 years from now on, if it is capable of dominating the results, which we don't know yet. So we will have some lighthouse applications, and this will extend, but I'm not quite sure if in 3 years every questions will be answered firsthand by artificial intelligence.
Maybe in 3 years, we will have another conversation, and that will be the application of AI in HR analytics.
Certainly.
We'll see. And Eberhard, actually, I think we still have some additional time. And given your fascinating background and that unique amalgamation of astrophysics and HR analytics, I think we have some time for the quickfire round as well. So if you have 5 minutes left and you're up for it, we can actually dive into that as well.
Yeah, please. Let's start.
Fantastic. So what is the biggest mistake that you almost made?
Unfortunately, biggest mistakes happen quite often when parameters are wrongly set in strategic business cases, for example. Just recently, our very last quality assurance step had taken one biggest mistake out. In the first moment, this was quite shocking for us, but then in the end, a big relief and quite fortunate because we didn't deliver wrong numbers. Unfortunately, in that moment, we had to extend our delivery timeline, but this was far better than providing wrong results.
So it turned out well.
Yeah,
good.
Luckily.
Yes. Next question is, what is the best piece of advice that you've ever received?
Yeah. If you know it's wrong, tell them it's wrong. They need to convince you. This was in my second consulting project when I returned to my project leader with some result, and he asked me, "You see it's wrong?" And I said, "Yeah, I know it's wrong." And he asked, "Why have you accepted the result you've received from the client?" And I said, "Well, he told me 5 times this was correct, and this was essentially the wrong decision. I shouldn't have accepted it, the obviously wrong result, although he had told me 5 times."
Yeah, I think this is advice that you can also employ not only in analytics and business, but also in life. And next question is, what is your most influential book and why?
There are various books, but there's one book on theoretical physics which gave guidance on my thinking. This is a lecture book by Eckhard Rephan, which taught me a crisp, precise, and reflected mathematical language on abstract matter. And this is in my studies, you start reading different books, and then there's this one book which exactly matches the language, how you can understand and describe problems. And this was the one which enlightened my world at that point of time.
That's interesting. Actually, to be honest with you, I was kind of keen to find out about your favorite book, and I kind of suspected that it will have to do something with astrophysics. You know, my understanding of astrophysics is, you know, limited to say the least. But I did read an interesting book by Max Tegmark, I think, the Mathematical Universe, or Our Mathematical Universe, which was very interesting. It was more, I think, tailored for the layman. Have you ever read that one by any chance?
No, I haven't seen that, but if you would send me the link afterwards, I will have a look. And
oh, good. I would be keen to hear from your perspective, you know, how valid is that. It was super interesting, by the way, so I will include both the links for both books in the description. And the next question is, who is your most influential public figure, and why?
Well, the question would be, is there someone which is guiding your thinking, or which is inspiring me? And there are ones, but typically they are not public figures. So at various point of time in the past, some stages in my career, there were people which were strongly impacting my thinking and had a long-term, are guiding me long-term in a long-term perspective, but neither of them is public figure.
Yeah, actually, one of your fellow speakers in Zurich will be Simon Hausworth, who is the SVP of Pricing and Analytics at GTA Travel, and he also has an astrophysics background. And on the podcast, he actually mentioned Stephen Hawking. So I was expecting maybe that name, but
yeah, well,
yeah, maybe next time. And the next question is, what is your favorite quote, and how do you put that into practice?
My favorite quote, and this is also one guiding title of my PhD thesis, is "More is different." This is the title of a scientific paper by P.W. Anderson, and this is bridging physical insight on different length scales. That means microscopic, mesoscopic, or macroscopic phenomena. So I can understand a physical problem when I'm talking about electrons and protons and stuff like that, but I can also understand the problem, or different aspects of the problem, when I'm talking about continuum matter and stuff like that. And this is very interesting and guiding in terms of, when I'm applying this in practice, that means that I can obtain sensible insight on various levels of detail, but in the end, all of these insights must correspond and talk to each other. So depending on the angle you are taking on a problem, you have a different view, different technique, and different insight.
Very interesting. And then the last question would be that what advice would you give to new and aspiring data leaders?
Get best in class in mathematics and start loving programming languages.
Okay. I think that's good for people both who aspire to succeed in analytics, but also in some other fields as well. So Eberhard, it was great to have you on the show. Thank you for the interesting insights, and well, look forward to finding out more and look forward to the details of the presentation in Zurich in March.
Thank you. Thanks a lot, and looking forward to Zurich as well.